Hello. So what I have open here is Tracer. This is a good software for visualizing MCMC outputs in the sort of trace type files. And what I've done is I've uploaded the file that we made in the last video to Tracer, and this is what we're looking at here is the file. And what you can see on the left here is all of the values recorded, or all of the parameters sort of recorded during that MCMC analysis. And the one we're kind of interested in is P, this probability of heads. And you can see I have the estimates tab open. And on it, you can see some good information about our posterior that we're estimating. And in our case, we estimated the mean to be 0.4937. And we can compare that to the true value that we simulated under. And it is 0.489 in this case, which is relatively close to what our MCMC estimated for the posterior. And another good thing to look at is the 95% highest posterior density interval, and we can see that our true value is within this interval, so that's another good sign. Another good thing we can get from this page right here is the effective sample size, and in this case it is 901, which is relatively good. Generally, you want a higher effective sample size. In Tracer, anything lower than, I believe, 100 will be flagged. And so that's a good way kind of assessing whether we ran our MC long enough. And another good thing we can do to kind of visually assess whether we ran it long enough is to look at the trace. And a good rule of thumb, but it's by no means a definitive way of showing that we ran long enough, is to look at our trace file and whether we want to see whether it's kind of bouncing up and down pretty regularly. And I guess one rule of thumb is whether you can say it looks like kind of a fuzzy caterpillar. In this case, it does. It looks relatively fuzzy looking. So we would say that this is probably, it's mixing well, is what we would say. And we can contrast that with another MCMC run that I did, where this just kind of slowly meanders about. And this doesn't look really anything like a fuzzy caterpillar in the last one that we looked at right here. And so, and what I actually did to generate this run is when we made our MV slide last time, we put a delta of 1 and then we tuned it. Now for this run, what I did was instead, we'll get right here, is I made a delta of 0.01. So we're proposing really small steps for each of our MCMC moves. And so I can rerun that analysis with these really small steps that we're proposing. And if we look at the operator summary of it, we can see that the acceptance ratio is 93%, which is really quite high. And that's how we generated this, because we can see that really it only ever moves pretty slowly and smallly at a time. And we were accepting most of the time. Now, kind of on the other side of things, if let's say instead of proposing too small of moves, let's say we proposed really big moves. Let's say in this case it's 0.75. We can rerun our analysis with really big moves. And then if we look at an operator summary, we can see that our acceptance ratio in this case was 0.06. So it's tending to reject moves most of the time. And in this case, if we wanted to visualize the trace, it looks like this. And it does look kind of fuzzy, but we would say that it's probably not mixing terribly well, because you get these kind of long sort of plateaus where the value doesn't change. So it's always rejecting value, or it's always proposing values that tend to get rejected. So that's why you see these kind of plateaus here, or maybe it looks kind of like buildings. If it looks like a skyline, a city skyline, we would say that that's a bad run. And if we want to compare the ESS values, or the effective sample size values, our first run that had that tuned delta, the effective sample size is in the 900s or 700 in the prior, whereas when we had too large of a delta size, it was in the it's in the 300s, and when we had too small of a delta, it's in the case of the teens, in this case they're all flagged by red, so that's kind of an issue that this hasn't run long enough, or it's mixing poorly. And I think this is best visualized if we go to this if we go to this sort of MCMC robot that we showed in the second video. So we will hide the fails, and we will adjust our steps. So as we said before, this is kind of represents the area of highest posterior density. This is a middling area of posterior density, and this is a low area. And if we run it, it should kind of meander all about, but generally we should see dots, the most dots within this circle, some here, and not very many outside. And it looks like it did a pretty good job at estimating that. Now, alternatively, let's say we did that second case where instead of having a step size of 50, we had a really small step size. So this is kind of similar to that case we had where we had a really small delta. We can see that it very slowly meanders about, and it kind of tends to hang out the most in this big circle and a little bit here, but it takes quite a while. You're going to have to run this for quite a while if you want it to really get a good picture of this space. And if we wanted to visualize the failed proposals with these purple lines, we can see that it's not really, we don't see too many of these purple lines. We ran it 3,000 times, and we can see that there's not very many of these purple lines for our 3,000 runs. Alternatively, if we ran things if we took very big step sizes on average, and we reran this, we can see that, well, first, we don't seem to have that many dots for 1,000 steps, and that's because quite a few of them got rejected. And we can show here that there's a lot of purple here, so they tended to get rejected quite often, which is kind of a waste of computation. So that just kind of goes to show that you kind of want a middle ground for your step sizes where you'll get some rejections, but it's not excessively many. Whereas here, this 50, we seem to kind of get a good estimate of our posterior. And if we show the rejections, there's some, but there's not quite as many as when we had big step sizes. There's more than when we had small, but it's we need a balance between the two. So yeah, Tracer is a good way for visualizing your posterior outputs, and this kind of just goes to show that you need to think kind of carefully about the moves you propose and then how those moves are performing. So thanks.